As opposed to the inverse approach of solving system of linear equation, there's an alternative way which is quick and fast, and this is known as the Cramer's rule. This rule uses the approach of determinant to solve system of equation. And you might be wondering, what is the basic idea behind it? Let's analyze it with the system of equation on the board. So how can we solve for x and y by the use of Cramer's rule? The goal is to form the coefficient matrix first. So I'm going to denote that matrix with D, typically uppercase D. So what will be its elements? Well, just focus on the coefficient of those variables present in that system of equations. You notice that we have 4, 2, 1, and 3. So therefore, D will consist of 4, 2, 1, and 3. Please, in that order. The order is very, very important. Perfect. Now, the next step is to determine the matrix of variable x. And how do you want to determine that? That's pretty much straightforward. The goal is to replace the coefficient of x in the system of equations with the solutions, and also in that order. Well, a quick way in which you can do that is just to come right onto the coefficient matrix, get rid of 4 and 1 right here, since they serve as the coefficient of x variable, and replace them with this in that order. So therefore, d sub x will consist of 40 to 35 and 3. Perfect. Now the last one, which is d sub y. The process is the same, but in this case we are ignoring the coefficient of y. We have to exclude the coefficient of y, and that will be 4, 40, 1, and 35. So what have I done? I've excluded the coefficient of y, but replace it with 40 and 35 respectively. And these are the steps you have to pass through. Having done this, we can now proceed to the Cramer's rule. So the rule says that the value of x or whatever variable present in that equation will be equals to d sub x divided by d. Note, it has to be the determinant. Similarly, y will be equals to d sub y divided by d. So now the goal is to solve for their corresponding determinant. So what will be the determinant of this matrix? That will be 4 times 3, which is 12, minus 2 times 1, which is 2, which is simply 10. Similarly, 40 times 3 is 120, minus 35 times 2, that's 70. And the solution of that is 50. Now what about 4 times 35? That will be 140, minus 1 times 40, that will be 40. And that results in 100. So therefore, at the end of the day, the value of x will be equals to 50 divided by 10, which is 5, and y will be equals to 100 divided by 10, which is 10. And these are the values of x and y respectively. You can see how fast and easy this process is. And that is the basic idea behind Cramer's rule of solving system of equations. Example 2. So feel free to pause the video and try this question out yourself. Don't forget, practice makes perfect. So now let's proceed. Just like before, let's determine the matrix D first. So that will consist of the coefficient of those variables, and that will be 3, minus 4, 7, and 1. You notice that the coefficient of y right here is negative 4, and the coefficient of y right here is positive 1, and that is why we have it this way. Now d sub x. So d sub x will be a matrix similar to this, but the difference will be the change in elements of this column, and we are going to replace that with this, and that will be 1, 23, negative 4, and 1. Perfect. Now d sub y. This sub y will also be similar to it because they have something in common. but with a change in element, typically the element in this column. So that will be 3, 7. Then we are going to replace that with this 1 and 23. 1, 23. Keep in mind, this is the same way as if you exclude the coefficient of y and replace it with this, or excluding the coefficient of x and replace it with this. I hope you got that. Now let's determine their corresponding determinants. 3 times 1, that's 3, minus 7 times negative 4, that's negative 28. And if we compute this, we have 3 plus 28, as the negative will affect each other to positive, and the result will be 31. Perfect. 1 times 1, that's 1, minus 23 times negative 4. That will result in 92. Negative 92. And if we had that, the negative will affect it as well. We would end up with 93. And for the last one, we have 3 times 23, which is 69. Now minus 7 times 1, which is 7. And we end up with 62. So these are the corresponding values for the determinants. Now we can determine the value of the variables. X will be equals to the determinant of x, which is 93, divided by the determinant of the coefficient matrix, which is 31. 31 in 93 is 3 places, and therefore x is equal to 3. Now what about y? Y will be determinant of y, which is 62, divided by the determinant of the coefficient matrix, which is 31. And that will result in 2. So therefore, x is equal to 3 when y is equal to 2. And that is the solution to this problem. Hopefully you now know how to make use of the Cramer's rule to solve system of equations. Thanks for watching. See you guys in the next video. However, this is your exercise. So feel free to share your solution with me in the comment section below. Thanks for watching once again. See you in the next video. Bye for now.